Hello and welcome. My name is Antje Wolf, and I'm looking forward to present to you our approach on utilizing digitalization for tracing COVID-19 infection chains within healthcare institutions to build another brick in the wall against SARS-CoV-2. During COVID-19 pandemic, it became apparent that it is of high importance to early detect infection chains also within hospitals. Infection control specialists are asked for tracing and anticipating potential contacts as well as transmission events to be able to initiate suitable measures at the right time. Here, they can make use of the invaluable data produced on the healthcare system as a consequence of increasing digitalization in healthcare. However, although availability and accessibility of routine healthcare data is increasing, data is often heterogeneous, non-standardized, and distributed in various application systems, even within one institution. Consequently, data may exist and may be valuable for infection control specialists. However, it is currently not efficiently usable. For this reason, we aim at designing a standard-based, interoperable application system that supports infection control specialists by consolidating, analyzing, and visualizing relevant data needed for tracing COVID-19 infection chains in hospitals. Our solution is called COVID-19 Surveillance Smart Infection Control System, COSIRF-SMICS. The original idea of pushing such standard-based applications also in the context of infection control arose from the German Medical Informatics Initiative and is funded by the Federal Ministry of Education and Research. The initiative strives for establishing a national infrastructure to enable the secondary use of data within and across hospitals by fostering data standards and interoperability. HIMED is one of the funded consortia covering a quarter of all university hospitals in Germany. In the HIMED project, an open health data platform that enables standardized data access and sharing, as well as the development of application, is created. One of the apps for this platform is the Smart Infection Control System that was initially only designed for bacterial colonization cluster detection in hospitals. During pandemic, the German University Hospital Network Initiative was formed, aiming at bringing all COVID-19 related activities together. Amongst others, it supports the design of a standardized COVID-19 data exchange platform called Codex, as well as a testing and surveillance strategy platform in the so-called BFAST project. Consequently, the design of our COSIRF-SMICS needs to be aligned to these standardization methods and interoperability activities. That's why we decided to fully rely on OpenEHR as an interoperability standard for data representation. It is in use in the HIMED as well as in the Codex platform. Many sites already set up a so-called data integration center with an OpenEHR data repository, which they now need to enhance with the datasets needed for COSIRF-SMICS, such as laboratory findings, administrative data, and patient locations. The COSIRF-SMICS retrieves data from the data repository by using the standardized query language, AQL, archetype query language, and a standardized OpenEHR REST interface. The interface is completely independent of the underlying primary source system layer, making the application interoperable. Of course, also FHIR is in use for sharing data on a national level, which is why first, all OpenEHR models in use for COSIRF-SMICS are also aligned to existing FHIR profiles. And second, we assured that it's possible to use a component called FHIR-Bridge to transfer FHIR data into the corresponding OpenEHR model. The Firebridge is part of the software development kit of Airbase, which is an open source implementation of the OpenEHR reference model. CoreSurf SMICS itself is a .NET 5.0 Blazor server-side web application with different microservices. The core component, SMICS Core, connects via HTTP to an OpenEHR server for retrieving data. SMICS Core provides a RESTful API for communicating with other microservices, such as SMICS Visualization, which is a Node.js component implementing an interactive visualization interface, and SMICS Algorithms, which comes with R and Python analytic scripts. CoreSurf SMICS is openly available on GitHub, along with test data and a user manual. Test data comprise various patients with virology findings and counter information and exemplary movements and states within the hospital. Additionally, an open demonstrator is available on the web. The current version comes with 4 modules called Patient History, Epidemiology Curve, Contact Network, and Statistics. In the Patient History module, CoreSurf SMICS is able to visualize patients' movement and associated virology findings in an ostensive way so that spatiotemporal associations can be explored. In this view, all patients that have been selected are shown among each other within the selected time frame. Each row is a patient. The horizontal line represents a stay at one location. You can see a little shift in the line when the patient was transferred to another location. Clicking on the line makes the line colored in the patient, just as well in all other patients that visited this ward. By this, it is directly seen when patients were on the same ward at the same time. The small vertical lines represent the virology findings with their color showing the result of the SARS-CoV-2 test. The epidemiology curve shows statistical views on new or retrospective COVID-19 cases in a user-specified time interval and in a given context, such as a hospital or a specific ward. On the bottom, you can see the traditional epidemiology curve representing new COVID-19 cases per day. On the top, all COVID-19 cases are visualized. CoreSurf SMICS also can derive contact networks. Each circle represents one patient with its state. A red circle represents that the patient was tested positive. Each line marks the contact between 2 patients, and when clicking on the line, details about the location and the length of contacts are shown. With this module, CoreSurf SMICS supports the tracing of potential transmission events. Finally, CoreSurf SMICS includes a statistics module representing the reported COVID-19 cases in Germany, in a specific region, or in the hospital, as well as important hospital-specific measures such as the number of nosocomial infections. CoreSurf SMICS is developed as an interoperable application, meaning that it uses standardized, consented, open source information models which have been published. We successfully tested the application with commercial and non-commercial repository implementations of OpenEHR. Therefore, CoreSurf SMICS can be shared across institutions. Of course, institutions still have to extract and standardize their data to be able to use this app, but they can skip application development. Shortly, the SMICS algorithm microservice will be launched with an algorithm able of detecting epidemic events at specific locations. This algorithm was developed by one of our partners, the Robert Koch Institute, which is the government's central scientific institution in the field of biomedicine. Furthermore, related work already presented promising results in terms of time savings in identifying transmission contacts. However, they are not focusing interoperability in the extent as we do. Nevertheless, this makes us confident that also our app will bring added value. For this, large-scale evaluations will be another future step. Finally, we firmly believe that CoSurf SMICS has the potential to support infection control specialists in identifying infection chains in hospitals and in taking timely measures to contain these diseases. We invite all parties interested to collaborate in our effort to establish CoSurf SMICS as another brick in the wall against SARS-CoV-2. Some final remarks. This work is carried out, funded, and supported in these projects and organizations. If you have any questions, don't hesitate to contact me. For now, I would like to say thank you and goodbye.